Hello, my name is Jacob Thompson, and in this presentation we will be talking about the chi-square test of independence on our data set for the course. Our agenda for this presentation, we're going to talk about some assumptions before we get into the tests. Then we're going to look at our chi-square tests. We have a number of variables that we've tested from our data set, and we'll talk about those. We'll go over some takeaways for the presentation and then go over any questions. So just like any test of variables, we're going to need a null and an alternative hypothesis. For the chi-square test, our null hypothesis will read that there is no relationship between the first categorical variable and the second categorical variable. And then our alternative hypothesis will read there is a relationship between these two variables. Our rejection rule, we will reject the null hypothesis when p is less than our alpha, and our alpha in this case is set at 0.05. With the chi-square test, however, we have to include a strength test. So if we have decided there is a relationship there between the variables, then we have to find out how strong that variable is. And so our post hoc rule in this case, if we reject the null hypothesis, then we must conduct that Cramer's V test, and that will give us the strength of that relationship. So let's look at our first test. This test was a relationship test between num_cars and num_defaults. So in this case, we were looking at the relationship between the number of car loans that someone has and the number of defaulted loans that person has had. So our null hypothesis in this case is there is no relationship between num_cars and num_defaults, and our alternative hypothesis in this case is there is a relationship between num_cars and num_defaults. So as you can see from the results, there was no relationship. So assuming that alpha of 0.005 or 0.05, no relationship emerged. So our chi-square had 6 degrees of freedom. Our population 150, our chi-square result was 6.68. And our p-value was much higher than our alpha of 0.05. So in this case, we will accept our null hypothesis, and there is no need for a strength test for this particular test. For our second chi-square test, we are looking at the relationship between lit comfort and num_defaults. So this would be any relationship between the answers of a Likert survey related to a person's finances and the number of defaults that that person has had. So our null hypothesis in this case is that there is no relationship between lit comfort and num_defaults. And the alternative hypothesis will read that there is a relationship between lit comfort and num_defaults. So after running this test using the PSPP software, assuming an alpha of 0.05, no relationship emerged. In this case, we had 6 degrees of freedom, same sample of 150, so our chi-square result was 6.68, and with a p of 0.351. So this was identical to the previous test, and so no relationship. And so we do not reject the null hypothesis in this case. For our final test, we are looking at a relationship between num_cars and lit comfort. So in this case, it's a relationship between the number of car payments that a person would have and the results of a Likert survey related to their personal finances. So in this case, our null hypothesis would read, there is no relationship between NumCars and LitComfort. And our alternative hypothesis will read, there is a relationship between the two. So after running the chi-square test using the PSPP software, a relationship did emerge. In this case, there was 9 degrees of freedom, same sample size, and our chi-square value ended up being 450, and our P of 0. After running the strength, the Kramers V strength test, we get a value of 1, so a perfect symmetrical relationship between these two variables. And I think it's in this case easy to see how the results of a survey related to your personal finances could be more positive related to the fact that you do not have a car payment and vice versa. So let's look at our main takeaways. Chi-square tests are a good test for variables that have more than one value. Like in our examples, the Likert survey scale, more than one value for that variable. So that's where we're going to use these chi-square tests. PSPP is a great tool for running these tests. If one had to do these tests longhand, it could take quite some time and be prone to having errors, but using a software program eliminates those errors and the time that it takes to run these tests. We need to remember that we must conduct that strength test if we reject the null hypothesis, as we did in our final example. Well, thank you very much for your attention, and I'll open it to any questions.